Hey guys, today we're going to talk about proving a quadrilateral is a rhombus, and we're also going to talk about proving a quadrilateral is a square. First, let's start with the 3 ways to prove that a quadrilateral is a rhombus. Okay, the first way we could accomplish this is to first prove it's a parallelogram in general, right? Because a rhombus is a part of the parallelogram family. Then we're going to prove one of the rhombus properties. Specifically, we're going to prove that it has a pair of consecutive sides that are congruent. Okay, the reason why this is unique to a rhombus is a rhombus has all 4 sides congruent. So if we can show that it has a pair of consecutive sides that are congruent, consecutive is one after the other, okay, then we can conclude it's a rhombus. Another way is to prove that it's first a parallelogram and then prove that the diagonals bisect 2 angles of the parallelogram. Okay, this is a possible method, but I'm going to stray away from this one. I'm going to really focus on utilizing this first method, which I think will make it easier if you guys limit it to just one method out of all these multiple methods you could be using. Okay, the third way you could use is to prove that the diagonals are perpendicular bisectors of each other. Again, there's 3 ways to accomplish this, but I'm going to focus on the first way, okay, as I go through this example. So here we go. First, let's plot our given points. -3, -4, 5, -3, 1, 4, and -7, 3. All right. So here's the deal. First, I'm going to prove it's a parallelogram. Okay, to do this, I'm going to show that opposite sides are parallel. That's one way we could accomplish this. Okay, we know that lines are parallel if their slopes are the same. So let's start with finding this slope. The slope of this one is you go up 1, 2, 3, 4, 5, 6, 7. So up 7 and back 1, 2, 3, 4. Okay. Then we have this slope right here. It looks like you're going up 1, 2, 3, 4, 5, 6, 7. And back 1, 2, 3, 4. So these slopes are the same. Therefore, these sides are parallel. Let's check this one. You go up 1 and over 1, 2, 3, 4, 5, 6, 7, 8. And last one to check. You go up 1 and over 1, 2, 3, 4, 5, 6, 7, 8. Okay, therefore, these lines must be parallel as well. Okay, so we have shown that the opposite sides are parallel because the opposite sides have the same slope. Okay, the last thing we need to do is we are going to prove that it has, let's just look at the wording of this, a pair of consecutive sides that are congruent. Okay, so I'm going to say that this is the consecutive sides that I'm worried about. So this one and this one are consecutive. They're one after the other. So I'm going to find the length of AB and the length of BC. And if those lengths are the same, then we can conclude that this is a rhombus. So let's use the distance formula from A to B. Okay, the distance formula is x minus x. If I subtract a negative, it becomes positive. And then y minus y squared. That's going to be 8 squared. That's going to be 1 squared. So that'll be 64 plus 1, so the square root of 65. Okay, so I'm getting the square root of 65 for that distance. Now let's find the distance from B to C. So I'm going to use these two coordinates. It's going to be x minus x squared plus y minus y squared. Looks like we're getting 4 squared plus 7 squared. So that looks like we're getting 16 plus 49. And 16 plus 49 happens to give us 65. So since those are congruent, okay, we can now conclude that A, B, C, D is a rhombus. Okay. All right, and then the last example of the day, or the last topic of today, is going to be proving that a quadrilateral is a square. Okay, so if you think of the parallelogram family, right, we have a parallelogram on top, we have a rectangle, we have a rhombus, and when the rectangle and rhombus combine, they create the square. Okay, so in order to prove that a quadrilateral is a square, we're going to prove one rectangle property and one rhombus property, and that should be enough. So we could go with proving 4 right angles for the rectangle, and we could prove 4 congruent sides for the rhombus. So let's get started with this process. 1, 2, 2, -1, 5, 0, and 4, 1, 2, 3. Okay, I'm going to start with checking the slopes of all these sides. With the slopes, we're going to be able to conclude a lot of things, right angles or parallel sides. So the slope of this one, it looks like you go up 1 over 3. And for the slope of this one, it looks like you go up 1 over 3. For the slope of this one, it looks like you go up 3 back 1. And for the slope of this one, it looks like you go up 3 back 1. Okay, so the first thing we can conclude is that this is a parallelogram because opposite sides are parallel, given that the slopes are the same. Okay, we can also prove that there are 4 right angles, okay, namely here, 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 and here. The reason why I'm able to make this conclusion is if you notice, these slopes are opposite reciprocals. If they're opposite reciprocals, then these lines must be perpendicular, therefore those must be right angles. There are 4 right angles. Okay, and the last thing we need to check is, are these sides congruent? Okay, so we could do the distance formula from D to C. From D to C, that's going to be 5 minus 4 squared plus 0 minus 3 squared. That's going to give us 1 squared, which is 1. That's going to give us negative 3 squared, which is 9. So this is radical 10. Since I'm running out of room, I'm just going to simplify right here. Okay, then I'm going to find the distance from B to C. That's going to be 2 minus 5 squared plus negative 1 minus 0 squared, which that's going to give us negative 3 squared, which is 9. 9 plus 1 is 10. those sides are congruent. Okay, therefore, ABCD is a square. Thanks for tuning in.